Hello everyone, welcome to my channel, and today we will discuss chapter 3, Understanding Quadrilaterals. This chapter is all about polygons. What are polygons? A closed circuit made by line segments. All these five circuits are closed and they are made by line segments. So hence these are polygons. Will this be a polygon? No, because although it is a closed circuit but not made by line segments, so this is not a polygon. Few more examples. Again, no, this time it is made by line segments, but these circuits are not closed, so these are not polygons. uh, there are various type of polygons. For example, we have already seen triangles, we have already seen quadrilaterals, pentagon, hexagon, etc, etc. So understand this in the simplest way. Polygons with 3 sides are called triangles. Polygons with 4 sides are called quadrilaterals. Polygons with 5 sides are called pentagons, and so on. Because this chapter is on quadrilaterals, so we will deeply discuss quadrilaterals later on this chapter. But before that, let's discuss convex polygons, concave polygons, regular polygons, and irregular polygons. So, first one is convex polygon. A polygon with all the internal angles less than 180 degree. Take a look of polygon ABCD. Is this convex one? Yes, because every internal angle here, whether it is angle DAB, angle ABC, angle BCD, or angle DCA, they all are less than 180 degree. So this will be a convex polygon. Concave polygon. Now for concave polygon, polygons with an internal angle above 180 degree. See this figure. We can easily see angle ABC. The internal angle ABC is simply above 180 degree. So this will be a concave one. The third one, regular polygon. A polygon with all sides are equal and all internal angles are equal. So a square is a perfect example. Also a equilateral triangle is also a perfect example, because for a square every internal angle is of 90 degree and also all sides are equal. And for an equilateral triangle, every internal angle is of 60 degree and all sides AB is equal to BC and BC is equal to CA, so all sides are equal. Now the last one, irregular polygon. So irregular polygon, it does not satisfy the properties of regular polygons. Means all the internal angles are not equal and all the sides are not equal at the same time. So all these polygons are called irregular polygons. Uh, for example, a right angle triangle. For a right angle triangle, there is a angle of 90 degree. Then the rest of the angles, it can be 60-30, it can be 20-70, it can be anything. So all the angles are internal angles are not equal. And you can take the second example, rectangle. For rectangle, although the internal angles are equal, but all the sides are of different measurements. Like AB is not equal to AD, and AB is also not equal to BC, and DC is not equal to BC. So all the sides are of uh, different measurements. So mm, a rectangle is a perfect example of irregular polygon. Now moving further, now it's time to discuss quadrilaterals, as this chapter is all about quadrilaterals. Quadrilaterals and its types. Mm, there will be different types we'll going to discuss, and their properties. Quadrilaterals, a polygon with four sides, as we all know. The first type of quadrilateral we're going to discuss is trapezium. So a trapezium mm, is a quadrilateral which has one pair of parallel sides. See figure, side AB is parallel to DC. There is only one pair which is parallel to each other. The sides AD and BC, they are not parallel to each other. So this is an example of trapezium. Can a square also be called a trapezium? Answer is no, because for a square there are two pair of parallel lines. See figure, this is a square. AD is parallel to BC and AB is parallel to DC. So there are two pair of parallel sides. So square is not a example of trapezium. Next type of quadrilateral is kite. A quadrilateral with two pair of equal length sides who are adjacent to each other. See figure. Side DC and CB adjacent to each other are of equal length to, and also side DA and AB adjacent to each other are also in equal length. So AD is equal to AB and DC is equal to BC. So this will be a quadrilateral which is called as kite. So, now the next one, parallelogram. A quadrilateral whose opposite sides are parallel to each other. See figure. AD and BC are opposite sides and they are parallel. Similarly, DC and AB both are opposite and parallel. So all opposite sides must be parallel to each other to satisfy the condition of parallelogram. So we can say square and rectangles are also a parallelogram because AB is parallel to CD and AD is parallel to CB. Now there are some properties of parallelograms. First one, that opposite sides are equal. Second one is the opposite angles of a parallelogram are of equal measure. So the figure is a parallelogram where opposite angles A and C and opposite angles B and D, they both are equal to each other. Angle A is equal to angle C and opposite angle B is equal to opposite angle D. So this is the second property. And the third one is the diagonals of a parallelogram bisect each other. So this is a parallelogram and there are diagonals AC and DB. They are intersecting at O and they are bisecting each other. That means AO is equal to OC and DO is equal to OB. Now time to discuss some special parallelograms. Uh, we'll be discussing three: rhombus, rectangles, and squares. First one is rhombus. A rhombus is a special type of parallelogram whose all sides are equal. That means AB is equal to BC and BC is equal to CD and CD is equal to DA. So all sides are equal. And the property of rhombus is the diagonals of a rhombus are perpendicular bisectors of one another. You can see diagonals AC and BC. They are creating angles AOB, angle BOC, angle COD, and angle DOA. And all these are of 90 degree. Now the next one is rectangle. We all have seen rectangle. Rectangle is a parallelogram which has opposite sides of equal length and its diagonals bisect each other. So this is a rectangle ABCD where opposite sides AB and DC they are equal, opposite sides AD and BC they are equal to each other, and the diagonals AC and DB they are meeting at O, they are intersecting at O, and when they are meeting at O they are bisecting each other. That means AO is equal to OC and DO is equal to OB. So this is a property of rectangle. Now the last one, square. A square is a parallelogram with all sides are equal, diagonals bisect each other, and the diagonals are of equal length. So this is a square with sides AB, BC, CD, DA. They all are equal as we know, and the diagonals AC and DB they are meeting at intersecting at O and they are bisecting each other. So that means AO is equal to OC and DO is equal to OB, and the diagonals are of equal length. AC is equal to DB. So these are the properties of square which comes under parallelogram. So I guess we have covered all from this chapter. I hope you will find my video very helpful. I'll be back with another chapter shortly. Uh, Thank you for your time. Please like and subscribe, and thank you for watching. See you again.